All right, welcome to the video on air pollution. We're going to go through the first six ones that are recognized by the EPA as air pollutants, and you'll see them here on the list. I'll go through each one though. So let's start with the difference between primary and secondary pollutants. A primary pollutant is just like it sounds. It's going to be the thing that's directly emitted into the air. It can come either from natural or human activities, natural processes. This could be things like bacteria in an anoxic environment releasing methane gas, or it could be something like a volcano emitting sulfur dioxide. Human activities is kind of what we're more focused on with this environmental course, and these all would be a good list of primary air pollutants released by various human activities, burning coal, burning oil, that kind of stuff. Secondary pollutant is what happens when the primary pollutants are out there kind of on their own in the real world and they form a reaction with something else. And so it can become some of these different things. And so this video, I'm going to focus mostly on primary pollutants. I'll make a mention of some of these like our sulfuric acid or the sulfate salts and stuff. This is kind of the process here. So these are the primaries, where they come from, and then how they can turn into sulfur or secondaries. So the first category is carbon oxides. There's two main carbon oxides to be concerned with. The first one of those is carbon monoxide. And with carbon monoxide, this is just CO. It's a colorless, odorless gas. The big thing with carbon monoxide is that it can interfere with our red blood cells' ability to carry oxygen, and so you essentially just pass out and don't wake back up for carbon monoxide poisoning. In low levels, though, it's still a pretty dangerous gas. It can cause like lung irritations and problems breathing, respiratory issues, even like short-term memory loss. So you might be doing something and kind of forget what you're doing. So it's not a chemical you want to mess with, or a molecule you want to mess with. Major source of this is through vehicle exhaust, and carbon monoxide is going to be produced anytime something's being burnt and there may not be enough oxygen getting to the fuel. And what happens is you essentially are producing this product without the recommended number of oxygens. Like CO2 would burn would be a product if you've got more oxygen molecules available. And so the places where we get carbon monoxide, we burn forests or grasslands. It's a lot of stuff burning at one time. Power plant smokestacks, right? Power plants are going to burn a lot of fuel at one time, and then inefficient stoves are going to have poor oxygen intake. And so all of these scenarios, you're burning something without enough oxygen, and that's when you produce carbon monoxide. Let's go to the next slide. Carbon dioxide is another air pollutant. I've got a little video here, which is why we had that delay. What the video is showing is if carbon dioxide was not a colorless gas, what our cities would kind of look like, what cars would look like. And so I thought it's kind of neat to put in here. I'm not sure how accurate it is, but it's certainly something to consider. Carbon dioxide produced whenever we burn anything, it's going to produce and release this carbon dioxide. It makes up 0.038% of the atmosphere, but 7% of the atmospheric carbon dioxide comes from our activities burning fuels, fossil fuels, as well as clearing forests and grasslands. The major concern with carbon dioxide, it doesn't have a lot of health risks or concerns with it, although if you breathe too much of it in, you're not getting enough oxygen. I guess you could suffocate, but global warming is where it's going to do the most damage, and we'll cover that later, probably in class actually. This is a good scale or good graph. It's showing carbon dioxide levels, concentration in Hawaii. And so something interesting from this graph is you get this kind of seasonal variation where come springtime, carbon dioxide levels drop because there's a lot of new plant growth that are pulling it out of the atmosphere and using it to grow leaves and sticks and things like that. And then as winter happens, those plants kind of die and the leaves decompose, and so it goes back up. And so seasonal variations are very common, but you can see the general trend line here is very positive slope, so it's increasing over time. And that's something, again, we'll cover that later. Another major pollutant are nitric oxides, and the two big ones here are NO, which is nitric oxide, and NO2, which is nitrogen dioxide. Both of these are going to form through the oxidation of fuels. especially like gasoline and coal and stuff. Any fuel that contains nitrogen compounds in it, or even any fuel that's burning hot enough to oxidize plain old N2 nitrogen gas in the atmosphere could produce one of these two things. And so the general process usually runs N2 gas is going to react with the oxygen gas when we're burning something, and it'll produce these nitric oxides, just plain old NO. And then when those NOs, which are being produced right where we're combusting the fuel, react with oxygen gas again, that's when we can form nitrogen dioxide. And so both of these are terms of air pollutants. Automobile engines are going to be the biggest ones here, but it is important to know that there's some natural sources of this, like lightning and soil bacteria, are going to produce nitric oxide. These are both big players in acid deposition. This nitrogen dioxide can easily form nitric acid, and photochemical smog formation, which I will cover later. There's another nitric oxide to be concerned with, but it doesn't have to do with burning of fossil fuels. That's nitrous dioxide, which is a greenhouse gas from animal wastes. And so that breakdown process of these really nitrogen-rich wastes can produce nitrous dioxide. This is another thing showing some of the environmental impacts. The two biggest ones are the acid rain production and photochemical smog, which is going to be this one here. But I'll cover them more in detail in a little bit. Sulfur dioxide is another major air pollutant. Sulfur dioxide can usually come from coal burning. Power plants, especially if we're not burning anthracite coal. Remember, anthracite's the dry, compact version of coal. Bituminous coal and lignite are very wet coals, and so they have a lot of sulfur in them. And so when they're burnt, that sulfur is oxidized into sulfur dioxide, SO2. And when that is in the air, that sulfur dioxide can react with particles in the air, water vapor in the air, to form sulfuric acid, which is H2SO4. That H2SO4 is a major role in acid deposition, right? This is sulfuric acid, and so these would be little droplets of acid suspended in the air. These sulfuric acid droplets can also react with ammonium to form ammonium sulfate, which is a solid particle, and that'll still be suspended in the air, and it can reduce visibility. Those can also build up in your lungs and create some problems there. But so that the ammonium sulfate is going to be a component of gray air smog, which is what you see in Asia and China, where they burn a lot of this bituminous coal. Another major air pollutant is particulates, which is kind of an overall, like an umbrella term almost, for just solids and liquids that are small enough to float on the air for extended periods of time. These things can build up in your lungs and airways and respiratory tracts and cause some damage. A real concern with the particulates is if you have particulates like lead, cadmium, or PCBs that are carcinogens or neurotoxins in the case of lead. And those things can be floating in the air, and so you're not knowing that you're being exposed to them, but by breathing them in, they kind of gather in those really sensitive, soft, vulnerable tissues, and over time they can lead to reproductive problems, genetic mutations, cancer, and so that's kind of when they become scary. The particulate size depends on how far it can get in. So our body has defenses to prevent these from getting into us and building up in there, but it's only good for such size particles. And so when we're talking particulates, we're usually talking less than 10 microns in diameter. And to give you an idea what that is, the human hair here is about 40 or about 50 to 70 microns in diameter. And so 10 microns would be about a fifth of that in diameter. And so something that's a 10 micron would be like dust, pollen, mold, etc. And so if you're breathing those in, a lot of those particles are going to get trapped in the nose and the throat. And so we've got like cilia in the nose and in the throat that are going to prevent those particles from making it any further. There's also mucus in the throat, which will catch a lot of these. Which is when you get like pollen and allergy irritation with them, it's typically happening in the throat and in the nose and in the head, not so much in the bottom of the lungs here. Smaller particles, such as combustion particles, these would be the things released when we're burning, our fossil fuels, organic compounds, VOCs, the PCBs, the metals, leads are going to be very small, less than 2.5 microns, and you can see them in the picture scale. They're very tiny particles. These things can penetrate all the way down to the air sacs within the lungs, which is very difficult to get them out once they're there. And so if you have a carcinogen like lead or PCBs stuck in the air sacs, essentially it's going to turn into cancer. Some other major air pollutants are ozone. When we talk about ozone as an air pollutant, this would strictly be tropospheric ozone. In the stratosphere, it's a good thing because it's going to block out the UV radiation up there, but also because there's nobody living in the stratosphere to breathe it in. And stratospheric ozone is a respiratory irritant, and you can see its list of side effects here. The process for forming tropospheric ozone is a secondary pollutant, and so it's going to happen when our NO2, our nitrous oxide, or nitric oxide, is going to react with sunlight. When it reacts with sunlight, it's essentially reversing the process that it was created from and breaking up into NO gas and a free oxygen atom. Oxygen is very electronegative, and so it'll combine with O2, just plain oxygen gas in the atmosphere, to form ozone. Typically, you're going to see this build up in the afternoons in congested cities and stuff. A lot of cars moving at rush hour is going to produce a lot of this NO2 gas because you've got a lot of sunlight in the afternoon, a lot of solar energy. That's when it would typically form O3. So you should typically see end of the day, rush hour photochemical smog being formed as a result of this secondary ozone production. This would be a picture of that happening. You can see the sun setting in the background here, and so this is happening towards the end of the day when there's a lot of cars out on the road and producing that nitric oxide gas. Another main air pollutant are volatile organic compounds. A volatile organic compound is a organic molecule that is able to turn into a gas and move through the air. And so methane is a very common one. If you remember the film Gasland that we watched, there's major issues with VOCs, in particular methane getting into the air and into the water. Benzene is another big one. This is an organic solvent that's used, very common one, and components of gasoline. And so this is a very wide range, and so there's no real VOC is this or VOC is that. It's a very broad category. As you can see, they come from a lot of different places, and they have a wide range of side effects. Lead is the other, and lead is kind of a success story. And the story goes that lead was used in gasoline for a very long time, since the 1920s. And the reason why we used lead in the gasoline was to reduce something called engine knock, which was an issue with the performance of an automobile engine. There's a lot of chemical companies really pushing for the benefits of lead in gasoline, and it was seen kind of widely as common and something that was required. But it came to a study. Someone was trying to actually study the length or the history of the Earth, how old the Earth was. And in order to do so, they were looking at lead isotopes. And the problem was they were unable to find a location or create a lab that had zero lead in it. And this kind of awoken them. People knew the concerns of lead poisoning, but they weren't aware of how much lead was being put out through burning lead gasoline. And so that lead would be in the particulates and be floating through the atmosphere and accumulating in body tissue. Even at low levels, it can be a potent neurotoxin. With lead poisoning, you're looking at things like reduced IQ, shortened attention span, hyperactivity, personality disorders, stuff like that. Lead poisoning is kind of attributed to the fall of the Roman Empire because their aqueducts were lead lined, and so all their water had lead in it. But in 1996, with the work of the scientists I was describing earlier, we were able to ban lead from gasoline and completely. And so if you go to the gas pump, you'll see the words unleaded on it. You can still find high lead concentrations near old roads, and airplane fuels are still going to use it. There's, I think, about 100 countries that have not banned leaded gasoline yet. These are typically developing countries where the gasoline regulations are a lot less strict, and they can get away with kind of a dirtier product. We'll stop it here, and I'll pick up on smog on the next time. So thanks for watching. Please bring notes to class and be prepared to discuss.